Hello everyone, and today we're going to talk about events inside of our game engine. And firstly, I would like to explain you the basic ideas, the basic concept behind all of this stuff, and how all of this should work. And then we will go to some implementation and take a look at some code. So firstly, let's just start with what we currently have. Now we have our window class that is just an abstraction for window, and we have a realization of this class based on the platforms we are running. So if you are on Windows, then we use Win32 API. If you are on everything else, then we use GLVV. GLVV. Okay, so currently our window doesn't have any events at all, so we need to add some kind of container that will contain our events, and then at some point of our loop we will iterate through every single event that we have in this container and process them. So that's pretty simple, but the question is, what will be this event type? For example, what kind of event we can have? We can have a window resize event that will actually have a window size and window height, and also we can have, for example, a key event, and this will only have a key code. So how to combine them together to a one single type? So the answer is pretty simple. We will have a base event class that then we will inherit from this base event class and create our like window resize event, mouse move event, key pressed event, and all of this stuff. So that's pretty simple. And this event class will actually have some kind of useful function. For example, get event type and all of this stuff. So I'll show you later on in code. So actually that's pretty simple. But then the question is how we will add events, where we will construct these events and paste them to our queue. So inside of our APIs that we use to create our window, we have a window and we have events already created for us. And all of them will actually have some way to specify how you want to process your events and what type of events you want to process. For example, in Win32, you have a window process function, and in GLPV you have some kind of callbacks, but they actually similar, because what they do is they take a window, not take but give you a window, like function take, but you will actually be given with a window. So they give you a window, and the parameters, like parameters that specify what kind of events you actually have. And window is a window for which this event occurs. So that's pretty simple. That's how all of this works. And what you need to do, you need to take this window. Then from this window, you need to somehow know an event queue in order to add event to, because honestly these parameters will be enough to construct our event class. For example, window resize event. Yeah, so we will create this object of this class using these parameters, and then we need to send this object to an event queue. But how to do this if we doesn't really know where is our queue? So we need to have some kind of data to be like specified for this native window, for this like Win32 window or GLV window. So there is some kind of a user data pointer that we can set to this window. So we can set to this window some kind of a callback. This callback will actually take this queue, and like this callback will actually take an event, a base class event, and it will paste this event to a queue or to any other container that you want. So that's actually the idea. So here in this function we will take this window, sorry, not take this window, but take a user data pointer for this window, and then we will construct this event based on these parameters, and then paste this newly created object to this callback that we actually have. So that's pretty everything that I would like to show you, that I would like to explain you, and let's take a look at some code. So here in code, as I said, we will have some kind of base class event, and this event will actually have some useful function like get event type. We have here event type like window resize, all of the stuff. Also, there is like a category that is here, and we actually have like, so that's useful function for categories, types, and also we'll have a handle. That means that if we want to process, we can send it to like fast function, and if this fast function actually handles this event, it's set it to be true, and then the next function will not take this event. So we will talk about it later when we will add layers to our game engine. Just for now, it's currently not important. So we also have a container that is in event queue that actually has some add event and get front. That's pretty simple. We just insert to a queue and take some front value from the event from it and remove it. So that's pretty simple. Then we have inherited events. So we have a key events for every single key event that we have. So there is like a key pressed event, key released event, key type event. So the same way we have mouse events, and the same way we have Windows event. Not sorry, not the Windows, but window events. So we actually have this event queue inside of our window, and we have a process event function that actually goes through every single event inside of this queue and just dispatch them using our dispatcher. So that's pretty simple. Currently, we are not focusing on it. We will talk about it later when we add layers to our game engine, but currently it's not what we would like to talk about today. So in our Windows realization, like Windows window, we have window process, but first let's just take a look at how we actually add this user data. So we specify something like an mdata. Mdata is a Windows data that takes properties of our window and also a callback that takes an shed pointer to an event. So we actually set this callback after we create a window. So if window created successfully, then we set this callback. This callback actually capture this and take events queue and add some events to it that are pasted to this callback. So then we actually set window long pointer. It's like mnative window, so it's like a handle window inside of Win32 API, and we specify that that's user data, and then we actually set this data to it. So in this window process function, we actually retrieve this data using get window long pointer, and we use our native window and actually the data that we want to retrieve, and we cast it to window data pointer, and then our data actually have a callback, and based on the event we actually have, we construct this event and paste to our callback. So that's pretty simple, the same way GLPV works. So we have initialize event callbacks, where we like have the same mdata, so it's like a properties and callbacks, and we specify this callbacks is just the same, and we have all of this, as I said before, callbacks inside of GLPV. So our Win32 API actually have just one function, window process, but GLPV actually specifies with a lot of callbacks. So we actually create callbacks for every single event that we want to retrieve, and we do the same things that we did in Win32 API. So that's actually it. And also I changed a little bit our run loop. I talked about it in the last video. So here we add some kind of windows vector container of windows that we have in our application, and we go through every single window, and if it shouldn't close, then we process events for this window, and if it should close, then we unregister it and delete it, because we allocate this using new, so we need to delete it using delete. What is register and not register? So register is just simple functions that take some window and add it to our vector, and unregister is actually the opposite. So it takes a window and delete it, like remove it from our window. So that's actually it. pretty simple, and I can say that that's that's good. And we actually want to compile this fastly. And also, you know what? I would like to add some kind of code. Um, let's just try to work with this. So key events, and I just want to test key type event. So if our event, we can get event type. So if our event type is event type key typed, so if our event type is key typed, then we can auto key. So we need to statically cast this event to our event, like key type event, but to a reference, because also it's a pointer. So something like this. So we cast it, and then we want to use Raccoon Engine Core info to just add, like to print this event to our terminal. So key has like get key codes. Okay, let's just try to do this. Let's just see if everything works normally or not. So there is some kind of cast to pointer from integer. Oh, that's a warning. Okay, so that's good. Let's just close this window and try to type something. Oh, I do something. Oh yeah, I cast to char pointer. That's why I have a warning. Okay. So also, what is a key type event? It's just an event that takes what you actually type, not what key you actually type, but what actually char you type. So if I change a language, this event will also will take another char. So let's just type like Raccoon. So everything works perfectly. And if I switch to, for example, to Ukrainian, I can type like some numbers will be the same, but when I type letters, they are not supported, so they converted to like English alphabet, and that's currently wrong. So yeah, that's everything I would like to show you today, and don't forget to subscribe to this channel, hit the like button, and leave some comments below about what you think about all of this stuff. And next time we will add layers to our game engine. And thanks for watching. See you next time. Goodbye.